Welcome to EDU World Space.
So for part A, we have a full tank. And so we can say that the force of a full tank would be equal to the buoyant force on that tank minus the total mass times G. So this will equal the density of the water times the volume of the tank times gravity. And then this will be minus the mass of the tank plus the mass of the air times G. So we can say that the force on a full tank would be equal to 1025 kilograms per cubic meter times the volume of the tank, so 0.0157 cubic meters, times 9.8, and then this will be minus 17 kilograms times 9.8 meters per second squared. And so we find that the force on the full tank of air is going to be negative 8.89 newtons. So this would be downwards. So essentially, the buoyant force of the air within the tank doesn't account for the mass of the tank itself. Therefore, it still will sink. Now for part B, however, we have an empty tank. So we can say that the force on the empty tank would be equal to the force, the buoyant force minus the mass total times G, which would again be equal to the density of the water times the velocity, the volume rather, of the tank times the acceleration due to gravity minus the mass of the tank times G. So here we don't have the mass of the air anymore because, again, the tank is empty. So here, the force on the empty tank would be equal to uh, 1,025 kilograms per cubic meter. That is the density of salt water times 0.0157 cubic meters. That is the volume of the tank, minus 14 kilograms. So that would be the mass of the tank, and then times G, so 9.8 meters per second squared. And we find that the force on the empty tank will be equal to 20.51 newtons. And of course, this would be upwards, which means that the tank, when it is empty, will float. That is the end of the solution. Thank you for watching.